Point P has coordinates x, 3, 2. And the point Q is the image of P under the transformation reflection in the plane y equals 0. Write down the coordinates of Q. Okay, so what is going on here is this point is going down to here, where this is y equals 0. An analogy would be to do the line y equals 0, then a point, say 3, 1, the x-coordinate would actually stay the same, but the y-coordinate become -1. And that is exactly what is going to happen here. So we don't even need to write the matrix down. Q is simply going to be 8, but the x value staying the same, then -3, 2. If you wanted to do a matrix transformation, then you could. So we want x to stay the same. That means we need 1, 0, 0. Then y to become -y, 0, -1, 0. And then z to stay the same. Okay, so just be aware of that matrix. It's not like you have to necessarily learn it, but we can generate it like that. If you did apply this to 8, 3, 2 here, you would get 8 minus 3, 2. Then we're told that the point R is the image of P under the transformation rotation through 120 degrees, anti-clockwise about the y-axis, with respect to the right-hand rule. So we're given that above. Okay, so I want to find out what the coordinates of R is. So I'm going to just use the matrix up here, but replace all the thetas by 120. Cos 120, 0, sine 120, 0, 1, 0. Sorry. Minus sine 120, 0, cos 120. Applied to 8, 3, 2. Okay, and you can put these in your calculator. So this gives -1/2, 0, √3 over 2, 0, 1, 0, minus √3 over 2, 0, -1/2, 8, 3, 2. Okay, then we're going to multiply this out. I'm going to get 8 times -1/2, that's -4, plus 0 plus √3. Then I just get 3 down here. Then -4 √3 -1. So that's going to give me R. Wait, I can't actually fit it all in there. So R, I'll write √3 -4, 3, and -4 √3 -1. Hence find PR, the modulus, or the magnitude, giving our answer as a simplified surd. Okay, well, let's first of all find it as a vector. If I want to go, so from the origin to P, the origin to R, then we can see P to R is going to be minus PO, PO, which is minus OP, plus OR. So it's OR minus OP. Now I'm going to write these in vector form. So, actually, sorry, that's not quite a vector, is it? Looks like I'm writing it as a matrix. So, √3 minus 4, 3, minus 4 √3 minus 1, and minus our 8 minus 3, 2 from before. That becomes √3 minus 12, 0 here, and then minus 4 √3 minus 3. Okay, so therefore the modulus of the magnitude is actually just going to become 2D Pythagoras, √3 minus 12 squared plus minus 4 √3 minus 3 squared square rooted. You need to do this by hand. If you put this in your calculator, it will give you a decimal. So we're going to be root 3 times root 3 plus 12 times 12. Then it'll be minus 24 root 3. And then plus 16 times 3, that's 48, plus 9. And then I'm going to get plus 12 root 3 plus 12 root 3, so plus 24 root 3. So that works out nicely because otherwise we've got the square root of a third. Actually, these cancel, so we don't. Then that gives a square root of 147 plus 57, which is the square root of 204, or simplified, 2 root 51. Okay, now we're asked to show that PR and PQ are perpendicular. So we've worked out PR. Here it is. So just need to work out PQ, which will be OQ minus OP. Now remember, Q was one of the early ones that we found. So 8 minus 3, 2. And then P was what we had before we reflected it in y equals 0. It was 8, 3, 2. Which is going to give 0 minus 6, 0. To show the perpendicular, we can take the dot product and obtain 0. And you don't need to say any more. We can just say, therefore, PR and PQ are perpendicular. Because remember, the dot product, you're actually also finding the magnitudes multiplied by cos theta. That means cos theta is 0, which means theta is 90 degrees. That's why it's proof. But it will generally be just accepted if you show the dot product is 0 that they are perpendicular. Finally, hence determine the exact area of triangle PQR, giving our answer as a third. So just a reminder, we had P up here, and then we had Q down here because it was a reflection. And we've just shown that PR and PQ are perpendicular, so R is going to be going along here, and this is our triangle. We've just shown that PQ is 0 minus 6, 0, which actually means the magnitude must just be 6. And then previously, we found that PR, the magnitude was 2 root 51. And that's all we need, because remember, this is a right angle. So the area is going to be a half times 6 times 2 root 51, which becomes 6 root 51. Brilliant.